7.1 Equivalent rational expressions. Whenever we see rational, what I want us to think about is fraction. Don't freak out! Fractions are our friends. Everything's going to be all right. We're going to take this real slow, step by step, and we're actually going to be reviewing some of our fraction rules, which is pretty awesome because I know that me personally, I can always review my fraction rules a little bit. First of all, let's just take down a definition of what a rational expression is. So a rational expression is an algebraic expression that can be written as a quotient of two polynomials. First, let's write this down, and then I'll explain it. So a rational expression is an algebraic expression that can be written as the quotient of two polynomials. Alright, so algebraic, it means it has lettery bits and numbery bits. Expression, that means that there's no equal sign. Okay, we are going to be solving rational equations later, but all we're doing right now is dealing with the expressions. Kind of like what we did in the beginning of our radical expressions. What we wanted to do was first get our skills up in simplification, and then we want to apply them to solve equations. So we're just dealing with the expressions right now, so we don't have to worry about like equal signs or inequalities or anything like that. That can be written as a quotient of two polynomials. Guys, all we're saying is that there's a poly on top and there's a polynomial on the bottom. Okay? So instead of saying poly over poly, what I'm going to do is give you an example. So x squared minus 9 over 2x squared plus 5x minus 1. Okay? That's an example of one. Here's another one though. X squared. Why? Because we can always say that x squared divided by 1, all of a sudden we have a quotient of two polynomials. Okay? This has many terms. Well, it has one term, and this has one term. Remember, a constant function is still a polynomial, or a constant expression is still a polynomial. What I want us to do is to review some exponent laws because that's going to help us out a lot with some of the examples that we have today. All right. So what I want us to remember is when we're multiplying numbers with the same base. So if we have, sorry, not a. I want to do this. X to the a times x to the b is just x to the a plus b. What happens if we're dividing? X to the c over x to the d? Well, that's just subtraction. X to the c minus d. There's one more little tricky thing that I want us to remember is that if we have, let me go here, if we have something like x to the negative a, that's just the same thing as 1 over x to the a. This is going to be an important one, okay? There's one more thing that I want to talk about, and that is the negative 1 thing. What is that kind of thing? I'm going to let you know by showing you an example. Say I had something that looked like this. X minus 5 over 5 minus x. They kind of look the same. We can't exactly just straight up cancel them because they aren't exactly the same. What I want to do with the bottom one, just so that it looks exactly like this, is I want to factor a -1 out. So I say x minus 5 over -1. If I divide 5 by -1, I get -5. If I divide x by if I divide negative x by -1, I get positive x. If I just rewrite this, it's going to look exactly the same way as this. X minus 5 over negative x minus 5. Now what we can go and do is we can cancel out these because they look exactly the same. And what are we left with here? We're left with -1. So if ever you see something that looks kind of like that, like x minus 5 or x minus 3 and 3 minus x or anything like that, what we can do is we can use that -1 thing to factor out a -1 to know that if I cancel this with this, it's actually -1, not 1. Or, like, you can still simplify it. This is not in the most simple stage.